everyone. Thanks so much for joining. I'm Alyssa Miles and I'm on the product marketing team here at Tailscale.
Hi everyone, I'm Kyle Dai. I'm on the monitoring team here at Apollo Research.
Kyle, thanks again for having Tailscale be a part of this launch. One quick housekeeping note for everyone watching. If anyone has any questions, you can go ahead and put them in the chat. Kyle and I are going to be jumping in to answer. And if we don't get to your question, feel free to drop it in Tailscale's Discord channel, which is at discord.gg/Tailscale. So I'm really excited for this conversation because so many engineering teams that we talk to are hitting the same challenge right now. AI workflows are scaling fast, but the visibility and oversight around them are still catching up. So a lot of our thinking at Tailscale comes back to this idea that flexibility is a feature for AI workflows, and we need to support this without creating operational chaos for everyone else. Because if you look at how teams are building right now, organizations just are not standardizing around one model, one framework, one coding agent, or one workflow. Teams are using different tools for different jobs constantly. Cursor, Cloud Code, Gemini, internal agents, direct APIs, MCP tooling, local models, hosted models, all inside the same engineering org, most of the time all inside the same afternoon. The challenge is that once those systems start connecting to real infrastructure, the visibility and governance gaps start showing up very quickly. And that's really what this conversation is about. How can organizations move from fragmented AI adoption to something a little more operationally mature without turning into the Department of No in the process? Okay, so here we're seeing the same pattern of pain points over and over that folks are hitting once their AI usage starts scaling. The first is visibility. It's that black box syndrome. Most organizations still can't confidently answer who's using what, which models are being accessed, which agents are making decisions, where are provider keys living, and what are the agents actually doing. Often there's visibility into pieces of that story, but not really a cohesive picture across the environment. Then pretty quickly, that turns into a governance problem. Once AI systems start touching internal infrastructure, production environments, shared engineering systems, and autonomous workflows, teams need a reliable way to understand who did what, through which agent, using which identity against which systems. And reconstructing that later from scattered logs and shared credentials is not usually a great experience. At the same time, the environments themselves are becoming increasingly fragmented. Because like I said before, in practice, engineering orgs are using a mix of models, agents, and workflows. That flexibility is the reality of how teams are building and should be treated as the feature that it is. Then there's the API key sprawl of it all, which I think most security teams are starting to feel just in their bones a little bit. Provider credentials end up on laptops, inside local configs, CI systems, scripts, containers, and every other place infrastructure quietly accumulates over time, and it's a nightmare to manage. And finally, there's the operational forecasting and cost side of this. Because AI usage scales fast once it becomes useful, a few engineers prototyping something turns into broader organizational adoption pretty quickly, and suddenly teams are trying to understand which workflows are becoming operationally important, where costs are going, how activity maps back to identities and environments, and whether any of this is still understandable enough to operate responsibly. Preferably without needing 12 disconnected dashboards and maybe a group therapy session afterwards to piece it all together. So the goal here is not locking AI workflows down or forcing everyone into one approved way of building. It's creating an operational foundation around AI systems that stays flexible as adoption grows without turning the whole thing into an opaque mess 6 months later. And that is where Aperture fits in. At the simplest level, Aperture is a gateway between users, agents, AI tools, and model providers. It sits directly in the request path between the thing making that AI call and the model receiving it. So if you've seen other AI gateways before, some of this architecture will feel super familiar. But the cool part is really how Aperture handles identity. Because Aperture runs on top of Tailscale, it inherits something that already exists in the network itself. Oh, and real quick, For anyone who's not quite as familiar with Tailscale, at its core, it's an identity-based mesh network. A lot of people know us as like, oh yeah, the VPN replacement folks, which yes, is totally fair. But underneath that is this identity-aware networking layer where connections already carry context about who or what is making the request. And the reason that matters in AI environments is that a lot of tooling still revolves around passing around API keys. So imagine this pretty normal workflow. An engineer is using Cloud Code connected to internal systems, maybe an MCP server, GitHub, internal APIs, cloud resources, whatever they need to actually get the work done. In a lot of environments today, the way that access gets solved is basically, here's another credential, another API key or token or secret sitting in a config somewhere that somebody eventually has to rotate later, which, to be fair, does work for a little while. But once those workflows spread across engineering teams, CI pipelines, containers, and automated systems, the operational overhead starts piling up pretty quickly. But with Aperture, I told you we'd get to the cool part. Identity is already attached to the connection itself through Tailscale. So instead of, okay, which API key is this, you can start answering which user, device, service, or agent is actually making the request. And operationally, that changes things pretty significantly because policies and visibility can map directly to identity instead of shared credentials floating around environments forever and ever, amen. What's also so important is that teams don't have to rebuild their workflows to get there. So for tools like Cursor, Cloud Code, Gemini, CLI Codex, and similar coding agents, setup is as simple as pointing the client at the Aperture gateway and using a custom base URL. There's no giant migration project or any of the great news, everyone. We standardized innovation, which historically does not get a huge round of applause. And then for custom agents and internal tooling, requests route through the Aperture gateway, which keeps provider credentials centralized instead of slowly spreading across environments as usage scales. And once requests are identity aware by default, you can start building a much clearer operational picture of what's happening across AI workflows. So not just AI usage exists somewhere, but which users are interacting with which models, which agents are making requests, how token usage maps back to teams and environments, what MCP tool calls are happening, how providers are being routed, and what activity actually looks like over time. Then policies extend naturally from the same identity layer. So access decisions can be based on users, groups, devices, machine identities, and tags instead of trying to reconstruct accountability later from scattered logs, shared credentials, and screenshots that somebody dropped into Slack like 3 weeks ago. And that distinction matters a lot more once these systems stop being side projects and start becoming real engineering infrastructure. Because at that point, organizations need visibility and governance that scales with adoption without forcing everything into one lockdown ecosystem to get operational control. And that's also why integrations matter so much. So most teams already have existing security, compliance, monitoring, and policy tooling that they rely on. So the goal is not rebuilding the stack from scratch. It's making AI systems operationally understandable inside the environments organizations want to use. And so because we are definitely sick of me talking at this point, Aperture gives organizations visibility, identity and context, and policy enforcement layer that they need to make AI systems operationally understandable. But once coding agents start operating across engineering workflows, the challenge shifts to understanding how those agents are behaving over time. And with that, I hand it over to Kyle.
Awesome. Thank you, Alyssa. Just move on to the next slide. So as Alyssa mentioned, engineering teams are heading towards hundreds of coding agents running across their code bases. These agents often have as much access as developers that are human and sometimes more. They can operate continuously, work at scale, access code, tools, credentials, and infrastructure, and understand large parts of the code base better than single engineers themselves. My question is, right now, could you tell if an agent was doing something malicious? For example, exfiltrating data, writing insecure code, or changing something it was never asked to touch. And would you even know what failures to look for? At Apollo, we've analyzed tens of thousands of real-world coding agent transcripts and identified over 60 recurring failure modes. Some of these are obvious security risks, and others are more subtle behavioral failures that quietly erode trust and code quality over time. On this first bucket, these are dangerous actions that you want to catch and block before they cause harm. So, for example, these might be an agent sending data to an external endpoint mid-task, or modifying a CI config to skip security checks. These are the kinds of things security teams already understand as risky. The second, more subtle failures are harder to catch from one command or one diff. You usually need to understand the full trajectory of what the agent did. For example, an agent silently ignoring corrections that the user made, or maybe swapping libraries or changing configs unprompted. And I know that we've all experienced these when working with Claude Code, Cursor, and Codex. These may not look like incidents in isolation, but over time they create a real problem. Engineers stop trusting the agents. How do we find them? The challenge is scale. A single coding agent session can produce hundreds of tool calls, thousands of lines of context, and sometimes millions of tokens. Now multiply that by every agent running across an engineering org. Manual review simply does not scale. And honestly, it shouldn't. Your engineers and security folks have better things to do. So what you need is an automated pipeline that surfaces only the sessions that really need human attention. It needs to understand both the obvious security violations and also the subtler behavior failures that affect quality and trust. The goal is not to review everything, but to find the small percentage of agent behavior that actually matters. And now, introducing Watcher. So that's exactly what we're building. We've spent years researching coding agent failure modes, so teams don't have to start from scratch in this regard, and Watcher is built on that research. There are two core beliefs behind the product, which I'd like to highlight. First is that you should have full confidence in the guardrails that you're using. So if you propose a new rule or policy, you shouldn't just ask, would this work in theory? But you should be able to test, would this have caught the failures that my team actually had? And that means Watcher backtesting rules and policies against your org's real session history. Second is that good security should speed engineers up and not slow them down. So every blocked RMRF, mistaken file edit, or overreaching agent is time an engineer doesn't spend cleaning up. The goal is not to interrupt developers constantly. The goal is to stay out of the way except for the tiny percentage of agent actions that actually need review. And now on the diagram that you see, Watcher has two layers. One for individual engineers, which we call Watcher Live, and the other is for security teams and engineering leaders, which we call Watcher Analyze. Watcher Live is for real-time intervention, so the guardrails. It runs on every engineer's machine, evaluating every command, file write, MCP call as it happens, and dangerous actions are blocked before they execute. Security teams set the non-negotiable guardrails for this, and then engineers can configure the rest within an approved policy envelope that looks different depending on if they're a product engineer or an infra engineer, for example. Watcher Analyze is the organization-wide agent behavior analysis. And don't worry, I'll show a quick demo of both of these after. Watcher Analyze grades historical coding agent sessions against Apollo's failure mode library, and it helps answers questions like what kinds of failures are showing up across the org, which teams or workflows are seeing the most risk. Are things improving RE guardrails and blocking dangerous actions week over week? What should we change in our policies? Aperture shows you what agents are running and what they accessed, and then Watcher Analyze tells you, was the agent behavior actually safe, and what should we change if it wasn't? So the feedback loop kind of looks like this. Aperture provides all this session history with tool call visibility, identity attribution, and then Watcher grades those sessions, identifies failure patterns, recommends policy improvements, backtests these against real history, and then applies these at runtime in Watcher Live for individual engineers. So over time, your security posture is improving. And now to just show you very quickly how this works. So in the spirit of not slowing engineers down, Watcher works wherever your developers work. I have a terminal here within Cursor, which is just a mock SaaS repo, where I'm essentially going to ask Claude to help me resolve a handshake failure. And on the left, you can see Watcher Live, the UI view of this, which you don't need to use, but some people have found it helpful in managing all their coding agent sessions. And you can also see all of the permission requests that the agent has gone through. Here, just to show quickly, so this example, we're opening a support ticket for this handshake failure, and I've hosted a seemingly realistic docs link, which I'll just click into and let this run. So here, actually, I've left in a malicious macro here, and we can see if Claude Code tries to execute this. So the idea is that Watcher only kind of intervenes when it has to. So in curling this docs link on its own, it's been allowed to go ahead and do that. Okay, but now it's trying to go ahead and execute this diagnostics bundle that is being specified, which is a big no-no. And we can also watch this happening in real time on this Watcher Live UI, but it's the same thing here. You can see Watcher deciding down here below the Claude Code session. As this runs, okay, there we go. So you can see this malicious command is trying to be run by Claude Code, but Watcher has blocked this from occurring. It's given us a reason for this, which is that the agent is trying to expose this vendor X API key from the environment variable, and then I can block this from happening, as in I can say no, or I can configure Watcher to just do this automatically for me. And now just to move on to the full session view of Watcher Analyzer. Here, I can see all the sessions across my org, as well as the one that I just ran. And in here, say if something has not been called by one of my guardrails, I can get to the bottom of and understand what has gone wrong and what I should do to improve my security posture from here. This example actually relates to one of the fuzzier failure modes that I'm sure we've all experienced, just to show you how Watcher would catch something like that. So coding agent traces can be very, very long. I'm just going to click on this AI-generated explanation of what happened, and then I can click through the trace a bit more purposefully to understand what happened. So the user here has asked Claude Code to fix the CSS in a specific submit button. And then Cursor here has actually gone ahead and refactored this hook and also modified a config file. And if I just click onto this, I can see exactly what it has done. And I know we've all experienced this and it's super annoying, but how can we stop this from occurring? And often individual engineers will configure their Claude MD files or maybe their memory MD files to remember these things for next time. But we can do one better. So things that we set from Watcher Analyzer also cascade down to the individual rule sets and policies and settings that apply in Watcher Live. So here we can require user confirmation before refactoring when assigned a bug fix. This is very specific. Or just in general, require user confirmation before modifying config files when not explicitly requested. And this is part of the monitor that runs over tool calls when they're made when they don't fit the static rule set that we've already defined. So these LLM-based monitors cover everything else, which is necessary in an agent-driven environment where the surface area of things that can go wrong is also endless. Just very quickly to wrap up, the idea is to improve the number of dangerous actions that you're blocking across your organization over time while reducing the number of sessions that are being flagged. I can see the number of different failure modes by category, so I know how to kind of prioritize my time in improving the security posture and just see how this is working over time. As Alyssa mentioned, as I'm deploying more and more coding agents, maybe different ones, over time and with different requests from different engineering teams. And that pretty much wraps up the demo here. And I will stop sharing my screen.
Awesome.
Cool.
I'm going to throw our slides back on the screen for a second because we of course want people to be able to try out Aperture and Watcher as well. So we've got some QR codes up there. They're safe. If you want to scan them, and you can download and try them. Kyle, for Watcher, can you download or is it a request?
For Watcher currently, it is a request, just
Okay.
because we've been setting this up in different environments, and often those can be quite different.
Amazing. Well, thank you so much for chatting with me today.
Yeah, of course. I've really enjoyed it. Thanks so much for having me.
Thanks. Bye.
Bye.